So I worked example 10 and 11 in chapter 6. They're actually both quite quick, so I'll do them together. So the first one we've got here is we're finding the derivative, it says, and it's got a 0 in here. Now the 0 that's inside the brackets here implies this is the derivative, or the second derivative at x equals 0. So what's the value of the second derivative when x equals 0? So our first step is to do our derivatives. First derivative of e to the 2x is 2e to the 2x. Derivative of the top goes out the front and multiplies out the front, so derivative of the power out the front, power stays the same. Second derivative, again, the derivative of the power goes out the front and multiplies, so this would be 4e to the 2x, the power stays the same. Now all we have to do for the second derivative at 0 is to do a substitution. 2 times 0, and anything to the power of 0 is actually 1. So this is 4 times 1, which is 4. So that means that our second derivative at the point x equals 0, the second derivative is equal to 4. And we'll talk about this in the next section, but this is a positive value for our second derivative, which implies something to do with the concavity of the graph, but we'll talk more about that in the next section. Okay, the next one, example 11, you've got y equals cos 2x. Find the simple expression for dy dx squared plus a quarter d squared y dx squared. If you wanted to write that in a simpler way, this is y dash all squared plus a quarter of y double dash all squared. And of course, looking at this, you can see, well, I'm obviously going to have to do y dash and y double dash for the first and second derivatives, and then substitute them in and try and simplify that expression. So our first job is we've got y equals cos of 2x. First job is differentiating. So derivative of cos is negative sign, and remember that the derivative of whatever is inside the trig goes out the front. So the derivative of that is a 2, and it's a negative sine 2x, because the derivative of cos is negative sine. Okay. For the second derivative, d squared y dx squared, I should say, we've got, again, the same thing. What's the derivative of negative sine? And if you've forgotten these ones, you can always remember, you know, your little tower of trig, sine, cos, negative cos. When you differentiate negative sine, you end up at negative cos. So we know that this is going to be a negative cos 2x, and we know that that 2, the derivative of what's inside the trig, is going to come out the front and multiply. So it will turn into a 4. Okay, so now we've got the pieces that we need. We can actually put them into our formula. So dy dx squared plus a quarter of d squared y dx squared all squared equals, put in dy dx, which is negative 2 sine of 2x, that's all squared, plus a quarter of this guy squared as well, negative 4 cos of 2x. Oops, a bigger bracket there. That's all squared. Now when you're squaring, what you are doing is squaring each of the terms. So we're actually going to square the trig part, and we're going to square this negative 2. Same here. I'll just get rid of the tower of trig here so I can get into it. When we're squaring here, we're actually going to square the negative 4, the coefficient out the front, and squaring the trig. So if we actually write down our next line here, we've got negative 2 squared. A negative squared is a positive. 2 squared is 4. So this is 4 sine squared of 2x. I've squared the trig as well. Plus a quarter of squaring the negative makes it positive, and squaring 4 is 16. And then squaring the trig as well. I've now got 4 sine squared 2x plus a quarter of 16 is 4, cos squared 2x. And you can see here what's going to happen, which is quite beautiful, is you've got in common the 4 that can factor out. Oops, I've missed a 2 in that one above. Just put the 2 back in. So now you can see I've factored out the 4, and we've got sine squared 2x plus cos squared 2x. We know that we have the familiar identity, which is that sine squared theta plus cos squared theta equals 1. It doesn't matter what theta is. Oops, it's a bit of a dodgy line. As long as these two things are the same, then this relation will actually be true. So it can be whatever you want in there. So in this case, our theta is 2x, and you can see you've got sine squared of 2x plus cos squared of 2x. So this entire thing in the bracket is actually equal to 1. So we've really got as our answer 4 times 1, which is 4. So that whole bracket is 1. So for this particular example, for your y here, a simple expression for dy dx squared plus a quarter d squared y dx squared all squared is found by differentiating y not once but twice. So you can substitute that into the brackets, and then after you've done that, using a trig identity at this point to simplify. So that's really the key thing there, which is in the question, find the simple expression. So it's not just finding an expression, but finding the simplest form of expression. So your answer for that one there ended up being 4 after all that work. So again, the key thing here with second derivatives, reading the question, make sure you're finding either the second derivative at a point or simplifying an expression where you needed to find the second derivative.